Well, this is our second workshop in the East Coast iteration of this series. Been going around the virtual world and telling everyone about Polygon. And we had a wonderful event last week, which is an introduction, which was not very enjoyable. I believe Steve's going to post the link in for that in case you missed it at all. And today we're going to go, that was Suraj who led that event. Very nicely done. I know a lot of you were here for that. So now we're going to take a little bit further and do more of a technical deep dive into Polygon and perhaps get you building some things as well. So without further delay, just FYI, this event will be recorded and you'll get the link for it afterwards along with the slides. Apart from that, I think we're good to go. Over to you, sir.
Sweet. Thanks so much. I really appreciate it. So let me just go on ahead and share my screen here. Before we start actually, I guess, like doing stuff, I think Suraj last week went over just some of like basic, if I have it right, like he went over like what Polygon is and various things that you can use on Polygon. Yes.
Yeah, a general, I think he even did a basic deployment or something, but yeah, just a general 30-foot view, really.
Sweet. Okay, I'm gonna just maybe spend like 5 minutes recapping some of the necessary things, and then we can get right into the building. So first things that we need for all of us. Oh, sorry, I should probably introduce myself first. Yeah. Hey everyone. I'm Xiangan. I am a developer relations engineer here at Polygon, and I am on the East Coast of the North American region. I'm in Boston. It's great to be here. It's great to talk to all of you. So today, we're just gonna get started with a little bit of how to deploy any dApp on Polygon, and then we're going to talk a little bit more also about like how do we deploy like very specific dApps, like how do we use like data oracles and other things on like maybe a few DeFi starter dApps and pretty cool stuff like that. So okay, let me just show you all a few things that we need just to like bootstrap the development environment. So first thing that we need is your faucet. Your faucet is here under Polygon faucet.technology. It's really cool, neat, and very intuitive link. All you need to do, and I'm gonna assume that you have a MetaMask, because you're not like way too brand new to Web3. So if you don't have MetaMask, it's all good. You can just go very easily to MetaMask, and there should be like a download for the add-on to your Chrome, or if you're using any other browser, same thing. But you just pop into your MetaMask here, and then yep. So I already have some Testmatic, but just to show you guys the process of getting that, just pop that into the wallet address box right here, and then it'll send you it'll send you one test token. One test token is far more than enough to deploy multiple times, unless you're running some sort of very complicated multi-call function that it's going to like eat up extraneous amounts of gas. I hope not. Gas is pretty cheap here in Polygon, and I don't think you'll run out. If you run out, you can repeat this process over the course of 10 minutes. It'll give you like a solid let's say like 10 to 20. Which should be quite a lot. By the way, just for future reference, whenever I say Matic, I mean Polygon. Polygon used to be called Matic before the brand change. So just for future reference. Okay, cool. So that's the first thing that you need. And for all the remaining other questions not immediately related to building, I will answer towards the end. So the second thing you need is Polygon Scan. Polygon Scan is there to make sure that your all of your various smart contracts are deployed correctly and can run here. They exist on Polygon. Today we'll be using Mumbai, the Mumbai version of Polygon, which is what this means is just the testnet version of Polygon. What we're going to be depositing today on the testnet before we, I guess, show you how to move on over to mainnet. Okay, and then the third thing is if you have any funds to bridge, you can use, sorry, not the bridge, but actually the wallet. You need to bridge or on ramp some funds on the Polygon before you can deploy to mainnet. I already have some Polygon tokens. I'm not going to be doing that over the course of this workshop, but so 3 things that you need. Yeah, so without further ado, I guess we'll get right into the building. So first, let's get started with just generally how to deploy any dApp onto Polygon, right? And I think this might have been covered yesterday already, but with Hardhat has or so I hear from some, it has a much easier kind of setup process than Truffle. And I mean, I guess there is some truth to that, but in my personal experience, I kind of took it for granted because I've been using Hardhat for so long, that I don't know. I think they're roughly somewhat the same, question mark, but whatever. So we have a really basic dApp here, that's already kind of set up. You can find this scaffold on Polygon Academy, and just for future reference, I'm just going to link this in a chat, for everyone to click on as I talk more about Polygon Academy in the future. But this is already on Polygon Academy. It has a lot of like boilerplate code written for you, such as your various things that you need to do to deploy. So this is your little, this combined with your hardhat.config are your, as well as this, of course. These are your various deploy scripts. You need these to essentially, get a account, like your depositing account, and then it'll wait for your collectible, which is your smart contract here, to develop. To deploy. And this isn't like a very advanced smart contract. It's just a basic like NFT smart contract, like inherits from the ERC 721 standard. It has a few utility function, like smart contracts also inherited into your collectible. And all we're doing here is just we're using a token counter for the token ID, which will increase 1 by 1. So there's going to be like token number 1, token number 2, token number 3. And then we also have a constructor that sets the base URI. So where is this NFT deployed? It's on IPFS. And we also have a function that's like, okay, we're gonna mint this NFT with a it takes in a 2 address, and this stores a token URI, just locally. It's impermanent storage with memory, and yeah. So we store this as its token URI, so that you can I guess you can look it up later. Okay, cool. So and by the way, whenever we fire off this function, and only the owner can call this, it's public, so when this publicly appears. But when we fire off this function, it increases our token ID by 1. So token 1, token 2, token 3 thing, and this always takes in a 2 address. So like, because we need someone to mint it too, right? And this 2 address is also corresponded here with this mint.js file, which essentially just has information on some of your NFTs and also the address this is minting to. So just a bit of context behind this specific dApp that we're booting up. But the more important main message that I wanted to put out there is deploying on Polygon is easy as setting your network that you want to deploy on to Mumbai, and then modifying your module.exports so then you can actually deploy on Mumbai. So right here, this is your typical like how to deploy your dApp on any chain kind of spiel. You have your RPC URL, which is just like kind of like I like to reference to this as like the window to your blockchain, but really you're kind of tapping into someone's node services and then deploying this smart contract via that person's node services. In this case, we're using Matic Vigil. Matic Vigil has been like occasionally wonky, but I think it'll work out for this one. yeah, so we have one that's for Mumbai, but if you want to deploy on actual Polygon, you can just switch this on over to Polygon. But also make sure to switch your front end, because we also have a lot of boilerplate front end hooks and various things, that depend on your that has this constants folder, which is like it depends on various assets for like which network that you're importing to. You should also change this to, let's see here. I guess it's listed as Matic here. So just you can just for simplicity's sake, you can just change this to Matic. But just make sure to do that before you get started. And then I'll just show you that this thing actually works. And it's first of all, it's that easy to deploy on any dApp onto Polygon, or Mumbai in this case. All right, we're just gonna wait for this yarn deploy to load, and in the meanwhile, I'll just also load up the cd yarn start. Okay, so it should be deploying. So it's reusing my collectible contract because I already previously deployed this. But if you're deploying this for the first time, you're gonna want to run a yarn mint to first mint all of your NFTs. I think Suraj ran over this yesterday, maybe not. So I guess that's why I'm trying to breeze through this. But if this is your first time booting this up, you have to first run yarn mint to mint all of your NFTs in IPFS before you, and also create this the necessary information here in the mint.js before you get the actual entire thing started. So yarn, right? So then you have to run a yarn generate, which would generate and yarn generate you should run for every so for every scaffold you have on our Polygon Academy. They're taken from our Polygon Academy site, and once again, Polygon Academy is there for you to if you're in a hackathon, or if you want to just quickly start on a product, just fork one of our starter kits that'll have a lot of really useful hooks and boilerplate written for you to essentially get you started off really, really quickly. But you should definitely do a yarn generate. That's required for you to have a burner account essentially to deploy your smart contracts with. So now we're on localhost, and here we are. So if we run another yarn mint, it'll mint me some fresh new NFTs, and then these will pop up all on the front end. So this is an actually existing contract on Polygon, and if you want to check it out, you can use Polygon scan and then search up the contract, and there you go. And I just want to really point this out because unlike at least from my personal developer experience, unlike developing on a separate chain, this is probably the closest that you can get to current state of Ethereum mainnet, and what you need to deploy is the same thing. Probably the one thing that this is rivaled by would probably be Optimism or Arbitrum. I mean, last time I checked, Arbitrum was still in whitelist phase, but this is extremely similar to how you would deploy any dApp on Ethereum. And for those of you who are already familiar with just deploying basic dApps, this should be really, really easy and not extremely difficult. Okay, but for those of you who are less familiar with general Solidity, let's do something more specific. So say if I wanted to let's say mint NFTs with specific rarity, right? And I think some NFT templates out there, because obviously everyone's minting and running NFTs nowadays, and I think some NFTs have this template that kind of stores a specific random stat on chain, so or something close to this. But this is how you call generally how you use data from an oracle. there's also very other specific things that you can do, such as making sure, for example, that each minting of your NFT gets one oracle call for for example, like a like verifiable randomness function that determines like, hey, what is this NFT like stat, like, right, from, for example, from like 1 to 100. Is your NFT like super strong like 100 or super weak like 1? It gets like a random number call for each NFT minted, based on maybe some sort of like mapping for each NFT token, token ID for each, like get random number results. Maybe you want to have that, but that's more specific, and I guess we can go over the kind of basics to that here, before I guess I can point you to some resources where you can like start building that functionality out. So same thing or similar setup we have here. So we have to first import our various libraries. So these are from 2 of these are from OpenZeppelin. So the typical like really basic ERC 721 standard, which is, as probably used for a lot of NFTs out there, or almost all. Or no, actually, I shouldn't say almost all. There's also 1155, but yeah, so used it for a lot of NFT standards out there. And then you also have the VRF consumer base, right? And what this does is it takes in some link tokens, chain link tokens, and then it mints for you essentially a random number. And this random number you can use for your NFTs and their stats. So what you can do here, and by the way, this is copy and pastable, and there's a solid amount of copy and pastable code on this specific contract here that is also from like Chainlink docs. What you can do here is you first log in the key hash and the fee, which is, and also you have like random results uint. These are all copy and pastable, which essentially just says the key. So the 3 parts that Chainlink requires for this function to run is the Chainlink VRF coordinator and the Chainlink link token. Link token is for the fees that this this function takes in to run. VRF coordinator is what it requires to run, and the key hash is also part of that. These are all different depending on which chain that you're depositing on, so be sure to look out for that. That's one of the things that you got to pay attention to, just generally when you're using oracles. So yeah, you first, at least for Chainlinks, you first have to fire off a constructor, and it will store in memory whether if an asset is for sale or not for sale. And this is for your specific NFTs, and we're building like an NFT market here, where if you mint an NFT, it'll be 1 of 1, and if you mint an NFT, it won't be for sale anymore. So great. So this is the same setup as you saw last time. So ERC 721, you set the base URI, but instead you also have a like a little like counter here to say if anything is for sale or not. So there's that. So you also have, so these 2 parts are copy and pastable. And then so the next part is you map each item to a Boolean value that says if it is for sale or not, which will obviously depend. If you've minted this already, you can't. It's not for sale. But if you haven't, it is. This also lets you look up a token URI. Sorry, a token biased URI. The token URI is just the IPFS hash. When you upload any image to IPFS, it has a certain, a certain like hash besides the original like base URI, right? And we're using that as like a token identifier. And this also maps this token strength stat to each token, which allows your NFTs essentially to have a strength stat that is confirmed on chain. So yeah, like truly on chain like NFTs, right? Then you this function get random number and fulfill randomness. These are both copy and pastable, but what this does is it just it gets you a random number, from this VRF consumer base here, and then it gives you it outputs a random result, and this is verifiable. It's one of Chainlink's products, super useful, really really great. So this next thing, we also have mint item here, and you can mint. This is like similar setup that we saw last time, right? Except the new thing about this is you have a token strength per token URI, and the token strength is a random result, from 1 to 100, and it's a UN8, and you add on the +1 here, so because we don't want anyone to have like an NFT with strength 0. And then we set this random result back to 0 because every time we call the random results, this is just like, because this is just manual, you have to call the random results once for every NFT you want to mint, and then this continues on to give you your random NFT. So we can just boot this up, and while I boot this up, I guess I'll answer some questions. Yeah, Polygon Academy I find is a really good resource, really intuitive. Yeah, I appreciate that. Thanks, Todd. I mainly maintain the repo. I definitely have like other people maintaining it with me. For example, the Siraj, which is our who's our lead of developer education, who spoke here last time. So yeah, let me know if you have any issues with that. I strongly appreciate it if you, I guess, like try out all the starter kits or whatever you use, and report issues as you see fit. Just to make everyone's experience better. Okay, cool. Hi, Xiangan. I've used hard hat deploy an ERC 1155 collection. When I see the contract and scan, explore silicon contract, mints, CMX with other interactions I did not perform. That's kind of strange. I mean, I haven't, I've never had that issue before, because you see every, example, and then we're going to do a yarn deploy here. I'm just going to deploy this contract, make sure the front end shows up, and then I can continue answering. But every contract has, if you instantiate like a new project, or sorry, a new contract. Also, sorry, I need to. My bad. I keep interrupting myself. My bad. Let's make an example, and then we're actually going to just do a yarn chain here. I think this might be on localhost for now, just to show you that this works. Where is it not? No, it's on. Okay, we're good. I guess this is just being a little bit slow. I've had this issue where like Polygon just doesn't display NFTs properly. So let's hope this works. If not, I can show you that this does exist on chain, and that I'm not embarrassing. Anyways, so I've never had that issue because whenever you instantiate like a new contract, it's supposed to have like a new list of transactions, right? Like you're not supposed to have pre-existing ERC 720 like transactions. Well, I guess unless you're like, because ERC 1155 is a token standard that kind of integrates both ERC 721 and ERC 20, because they're like transmutable under that the standard. It might just show up as an ERC 720 ERC 20 transaction. I'm not too sure though. Yeah, so that might be just that. But if you happen to see if you didn't perform the interaction, it might be a part of like what is going on under the hood to like make sure that things work. But yeah, let me know if you keep facing that issue. We can problem solve more in depth. All right. Sorry, let me just share another thing that I wanted to show you, another third dApp that I wanted to show you before we kind of jump into like Q&A and all the other things. I promised to like at least give you like 20 minutes of time to ask questions. And I can also show you more things if there's extra time. All right, so here we go. I'm going to reshare my screen. And then we have this last dApp. This is more like a kind of like a starter DeFi dApp. This is like a Polygon based like crowdfund starter. So I guess if you have like a new project that you want like to have like get funded on your own UI, from other people, I guess you can have that, kind of like just like a crowdfund or like a list of projects that you can set to like have crowdfunded. So we're gonna seed into crowdfund starter, and this is a very similar process, right? You have a pre-existing smart contract here. You have a pre-existing smart contract, right? Or if you don't, that's totally fine. You can still build this from the ground up. All you need to do is, first of all, you have to declare variables, right? Declare when the round starts. You have to have it when like the round duration, or how much the round duration is, and then you also have to have a recipient count. To instantiate this, you first set it to 0. And you also need to make sure that you add the immutable keyword to round duration, which just means that when you put it down, when you deploy this contract, you can't change the round duration, because you wouldn't want. Well, I mean, I guess you wouldn't want any potential ways for people to like re-enter or something like that. But anyways, that's a nice design feature. Not necessary, I don't think. If this is like just testing, but probably necessary if you're doing something more serious. And you also need various events. So you need various events that both the smart contract and your front end can interact with, namely when the round is started, when you add a recipient, when you donate, matching the pool donation, and when you distribute, to the funds. And there's a few modifiers here. If you're familiar with Solidity, or honestly just any coding language, this is what's a good I think this is similar to like a JavaScript modifier, where you can't, this is like a thing that you have that essentially prevents your functions from doing something, or makes it so that it has to do something in a certain way. So this is pretty basic. When the round is starting, or before the round is opening, and then this is going to get used in like the start round. So in order to start the round, you need to make sure that the round is not started yet, and so there's this modifier that gets slapped on right here. And this is also only callable by only owner. Only owner is a thing that is imported via this ownable library, which essentially just says that only the account that you're deploying this smart contract with can call the start round. So kind of like, I guess, a way to like decentralize it, just like deploy and forget kind of spiel, and make sure that no one else can call this, because we wouldn't want I guess people to just randomly call this whenever they want. Right. So your donations are only available when the round is open, also with a modifier over there, right here. You can also add recipients before the round is open, and that adding recipients part comes in when you deploy. So when you're just starting to deploy, you first deploy the smart contract, and then you can use ethers to call this your smart contracts add a recipient function. And this is how, this is kind of how you can interact with your smart contract via ethers. Ethers just allows you to kind of call various methods of your smart contract from a JS file. So yeah, right here you have you also have just like a thing that formats this into this is responsible for displaying each individual member that you're crowdfunding for. And obviously this is just like a quick example. You can replace this with actual addresses and try it out yourself on Mumbai before you deploy on mainnet. But yeah, you also have a 300-second deploy time, or sorry, your round funding time, which is just 5 minutes, which is enough for me to show you that this actually works. Yeah, so so that's the add recipient. You have a function that's get block timestamp, which returns the block time. This gets called when the round starts, and it sets the round start time to get block timestamp, which is like your current block time, and then it lasts for a certain while before ending. And then in the end, or you can also donate. So this is a public playable function, and it's only callable during is round open, which is when the round is going on. And so this requires that your so you have to well, this seems kind of silly at first, but you have to have this be from, oh, my Solidity just froze, or sorry, my Sublime just froze. You have to have this function be called for like an actual person in the funding round. And then this also emits a donate event where it contains a transaction origin. I think the event is also, so it's also here. So it has a address for the transaction address, has an address for the MSG.sender, which is like your whoever donated, right? How much they donated, and this index here, which is whoever got donated to. Yeah. So once again, this distribute thing, it also takes in it's an address payable, right? And it contains a, so first of all, let me just see here. So this is first of all only callable by the smart contract. So this is meant to be called after the round ends. And this is an external function. So it's like, I guess like you can call it, well, it's not that you can call it, but like this is callable by other smart contracts that are building on top of this, I guess. And then you also have a to transfer amount, right? And then you also have and then this also emits the distribute event, similar to the event up here. And what this takes in is an address payable to, the index just keeps count of like which person it is. And then you also have the address payable for to I guess like whoever is receiving the ultimate donation. Yep, and then you also have the donation amount. Okay, cool. So after explaining that smart contract, there's already like a publish thing for you. So you don't have to worry about this too much. You just have to worry about the fact that this is currently on localhost. But if you want to take this to like a test environment, do replace this with Mumbai. Not only here, obviously, but also in the front end. Wait, why did I just click on the hard hat? Sorry, I'm supposed to click on React app, go down to app.jsx, and you're supposed to also, so I added in this Polygon provider here. Just make sure that you're using this Polygon provider instead of, instead of the local provider or mainnet provider if you don't want to go to mainnet. I will leave that as a call to action for all of you to deploy onto Polygon. But just to show you that the like basic dApp works. So I'm gonna do a yarn deploy. This will deploy on my local chain, so I don't think it'll go wrong. And I'm also just gonna do another yarn start. Yarn start. Oh boy, what happened? Cannot connect to network local. Oh, right, because I didn't, for some reason, I exited out of my local blockchain window. Okay, that's fine. So I guess I'll show again how to boot up your local blockchain via hard hat. So booting this up is super simple. You can do yarn chain to boot up your local blockchain, or even better yet, you can, if you want to like build on top of some pre-deployed project, or let's say if you want to build on like Uniswap or Aave, right? You can go into a new terminal window and then do yarn fork, which will fork mainnet, and then allow you to play on your fork of mainnets instead of, I guess, a simple local blockchain. So as we can see here, this will boot up very, very soon. All right, and there we go. So this works. It's okay. I don't know if the ENS will work on Polygon, but you'll have to check that out. And I've previously already donated to the funding pool just to make sure this works, but you just essentially get 1 ETH over here. Oh, right, I need to copy my front end address. To test this out, you can get 1 ETH from your local faucet right here, and then you can put in 1 ETH support. Oh, right, I need to account for gas, right? So you can't just send 1 ETH, but you have to also account for the gas difference. There you go, you could send 0.5 ETH to it, and there it goes. You've just funded Whiskers widgets for half an ETH. And you can take this onto Polygon testnet and mainnet too, if you want to build something that's functional. Okay, so I said that I would leave a ton of time for question and answer. And I guess I'll do that right now. For now or later on, what front end flow do you recommend? Meta transaction versus transactions on Polygon. What is the recommended flow for onboarding users symptomatic that are not crypto native? That's interesting. I personally think that a lot of folks who've heard of Polygon must have already heard of MetaMask. Just because if you really think about it, right, like in order to come onto the like general blockchain ecosystem and to become irritated with Ethereum enough to want to genuinely like treasure the lower fees that Polygon provides, right? You're probably going to need MetaMask. But if someone is new to Polygon, I don't think like installing MetaMask is that much of a turnoff. I mean, unless they're like completely new. Yeah, I don't know. Just some of my thoughts there, I guess. Do all UVM apps and tooling work with Polygon? Yes, that is correct, and that's actually one of the reasons why like all those dApps were so easy to boot up. And honestly, kind of the main takeaway that I want to give you is the fact that if you wanted to learn how to be like a Polygon developer, you're essentially you just need to learn how to become like a Solidity/React developer, and that's it. Like as far as I know, most, if not all, like 90 to 99% of all EVM apps and tooling do work with Polygon. And if it's not, I'd be interested to see like the unique cases, I guess, when that doesn't work. What's on a development roadmap for Polygon? Yeah, totally, sure thing. Let me just show you. So let me just, I guess, give you a little bit of context behind like just general layer 2 scaling solutions and how we got to this point. First, we had state channels, and one of my really good friends actually worked on state channels, but those were the earliest form of like scaling solutions, where they I guess they're not as good as like Polygon proof of stake or zk because of like degrees of centralization. So recently, Optimism actually wrote a little thing about EVM equivalence, which I mean, like Arbitrum and Polygon are both working on already. I mean, I still think it is, once again, I think it's like super novel, right? This stuff is like really, really cool, and great job for the Optimism team. Several friends there that I extend my sincerest congratulations to. But yeah, this kind of illustrates, the first image kind of illustrates what I was talking about, where state channels had like a closed gate, right? Like it's very censorable and was only privy to member-only transactions. And then we moved over to Plasma technology, which is like, right now what we have. Anyone can transact and everyone can use tooling, but I guess it. But I mean, I guess to say that we're centralized wouldn't be accurate, because we do have, it's a combination between like Plasma and proof of stake, where we're not centralized because we have like quite a few node validators on Polygon, which are responsible for confirming like final transaction states and just making sure that your transactions have like mainnet level security. and everything goes through like properly, right? Then we're going from that to now rollups where anyone can interact, can transact. It's uncensorable and it's like a lot more secure. So I hope that answers your question. I know that was like a super long answer. I'm so sorry. But I hope that answers your question. Oh yeah, and by the way, oh sorry.
No, I just said awesome. I don't know if there's anything else you want to add.
Yeah, totally. I was just gonna say, you don't have to just build DeFi or NFTs. We're constantly, at least I'm trying to constantly, innovate new like repositories slash like quick forkable kind of bootstraps for all of you. I'm currently working on one that's like, I'm trying to deploy like a Circom based like dApp onto Polygon. I'm taking some time to just learn a little bit of like basic cryptography before I do that though. And also Circom is interesting. It's definitely different than what I've seen before. So it's going to take a small bit, but yeah, I'm still working on that for all of you, but let me know what you'd like to see. Like if there's any ideas as to like what you want to build, but you don't really want to write the boilerplate code for that, let me know. I can just do it for you via one of these quick scaffolds. And I mean, chances are other people want to build what you want to build too. So, you all should check this out. This is a very, very basic like starter kit. This is the like truffle / ganache version. But if you're like a modern cool kid and you want to like do hard hat, I also made a hard hat version for all of you. So do check that out. All right, that's about it. That's it for
That's
me.
fantastic. Another fantastic workshop. Thank you very much. And all of this, the content of this video will go up tomorrow. We might be having some more Encode Polygon programming confirmed very soon, which I don't want to jump the gun too much on, but it'll be very exciting for you to build cool things. In the meantime, thank you very much. Have a wonderful afternoon, evening, morning. It could be a morning in Asia, wherever you are, and we will see you soon. Thank you very much for your time.
Thanks, everyone. Appreciate
Bye, guys.
you.
Bye.